Hi, my name's Mark Halter, and I'm on a team with Jacob Thaxton, Shub Shahara, and Kanisha. And for our senior design project, we made an RC trailer jack. It's a remote control trailer wheel system. The types of clients that this system would be for are those that are recreational commercial trailer owners. So people who have campers, boats, or utility trailers, along with companies such as U-Haul. The current problem with trailer jack wheels utilized in the market is that they don't help you in any way once the trailer is removed in getting the trailer to a final position of preference. And so you may have to physically push the trailer that last distance to park it where you'd specifically like it to be. And in doing so, there's blind spots. So you might bump into things. Maybe you don't align it exactly the way you wanted to. It's physically difficult because the trailer has a lot of weight on it. And solo operation sometimes might not even be manageable. So our solution to this is a complete wireless ecosystem. Next, I'll pass it off to Jacob.
Thanks, Mark. I'll take it from here. If you look at the diagram on the slide here, we can see that the smartphone app communicates with the ESP32 over Bluetooth. The smartphone also communicates with the camera module as well to provide a backup feed to the user. Now, this ESP32 talks to the motor driver, which, as the name implies, drives our motors, which generates movement of the trailer jack. Right now, I want to talk about the engineering specifications that we set for ourselves. We wanted this trailer jack to be able to move up to a load of about 500 pounds safely at a speed of about 1 mile per hour, just to prioritize safety of the operator and so that things don't get out of control. We wanted there to be a wireless range of about 30 feet so that the operator doesn't have to be too close, so they can maintain a safe distance. And we set a 12-volt power requirement on a 10-minute duty cycle so that the component doesn't draw too much power. Now, regarding the third Keen C, Curiosity, we were curious about how a problem historically solved by manual labor could be solved with a wireless and easy-to-use solution. Not only to solve this problem, but also challenge ourselves to learn more about mechanical movements and wiring and problem solving. Now let's take a deeper look at some of the hardware involved in this project. So we started with a trailer jack that we welded to some motors that we pulled from a mobility scooter. Now these motors are supplied power from the 24-volt batteries. Now the 24 volts might sound like a lot for our ESP32 and other modules, so we used a step-down voltage regulator for the smaller components to provide only 5 volts. Now these smaller components are located in a weather-resistant enclosure that includes the ESP32, the dual motor driver, the step-down voltage converter, and our relay. I will now hand things over to Shub to discuss the software components.
Thanks, Jacob. Now, on the software and control side, the mobile device acts as the main user interface for the system. It sends commands wirelessly to the ESP32 through Bluetooth Lite and Wi-Fi. The ESP32 basically serves as the brain of the project, taking those inputs and translating them into movement commands. Those commands are then sent to Citron Smart Drive Duo, which is the motor driver that controls how much power goes to each motor. Since both motors can be controlled independently, the system can steer and move the trailer with much ease and precision. Altogether, this creates a smooth and responsive control chain. Next, we focus on the user side of the system. Our mobile interface gives the operator easy control over steering, throttle, braking, and different gear modes like park, reverse, neutral, and drive. We also added ramp up and ramp down feature so the trailer starts and stops more smoothly instead of moving suddenly. For safety, we included a fail-safe feature that stops the trailer if the signal is lost or if an emergency stop is triggered. We also added a live camera feed which gives the user real-time visual feedbacks and make maneuvering and alignment much easier. Now let's look at the real-life demonstration of our RC trailer jack on a full-scale trailer showing its power, control and ease to use. With that, I will pass it to Kanisha to talk about the success criteria we achieved through testing over the course of the project.
This slide shows that our RC trailer jack was successfully tested on a full-scale trailer. We were able to control the system wirelessly through our Android app using Bluetooth communication with the ESP32. The steering, throttle, and gear commands were sent in real time and they worked as expected. We also included safety features, so the trailer stops if the signal is lost or the brake is pressed. In addition, the live camera feed helped improve the visibility and made control easier during testing. This slide highlights the value and future potential of our project. The RC trailer jack reduces physical effort, improves safety, and allows one person to move a trailer more easily. In the future, the system could be improved by adding features like self-parking or maybe auto-hitch alignment and support for different trailer types. We could also make the design more compact and practical for the real-world use.